right. So, if you've noticed on today, it said that today's agenda is forthcoming. Today is going to be the first of a few different kind of review days. This is basically to make sure that we are checking in and catching up with you on this material, because this is the time when other classes start giving out a lot of stuff to do in class, as well as exams. But also we need to look at making sure that you are understanding for loops and the turtle operations like you're expected to. So today we're going to go over a few different, I'm going to go over actually some questions from an old quiz that I gave when this class was over during COVID and I could not reliably proctor the class. So a lot of this was kind of, here's some questions, it's a quiz, there's a time limit, please answer it, but I can't proctor you properly because that's actually impossible. And those kind of those monitoring, software things were actually kind of too many false positives there for students and issues with that. Too many technical issues for me to handle. Were there some students who probably got away with cheating? Yes. Were there students who I caught cheating? There were a whole lot that I caught because because again, just keep a look at the the number I put on the front of the syllabus. If you don't believe me, there were a lot. All right, so I've updated the Discord link. This is good for 25 more uses. So if you haven't joined Discord yet and need to, and I'll probably replace it later with a more permanent link. But for right now, that will work. All right. So what we need to do now is that we again want to just kind of check in with everybody on how all the for loops are going. So is there any confusion about for loops and how they're working? I think a lot of confusion, there's some confusion and issues around nested for loops. That can be a bit tricky. And we, in the assignment, in lab 2, in lab 4 and 5, there's a lot of operations that go on with these nested loops but also there's operations which involve nested loops but don't look at because you've got functions calling functions, right? So let's see here. Yes, scene. There we go. Somebody mentioned that had accidentally happened, so I'm going to go ahead and remove that scene. Yes, I don't want the web camera. I just want that. There we go. Okay. So there we go. So you can put, again, any kind of, with indentation, we can use kind of any statement with indentation you can put, and blocks of code, you can put for loops inside of for loops inside of for loops inside of for loops. Generally speaking, nesting a for loop in a for loop is annoying and frustrating at this point, but it's fairly standard to do that. Nesting any more than 2 at any point is considered cruel and unusual. Yes, there's probably situations where you're going to need to do that, but if you're going to do that, then at that point you might as well functionize it, basically turn those inner loops into functions that then get called. Organization's the name of the game. You want to make it easy for yourself as well as the person who's going to be reading your code 2 weeks from now, which is going to also be you, but a wiser and hopefully one who's gotten a bit more a wiser you, and hopefully one who's gotten a bit more sleep. So a for loop is fairly straightforward, right? We've seen this for I in range, and if I do 5 here, right, print I, right, we're going to print out the values. Okay, and it tells me to save it, right? That's okay. Let's go ahead and write classroom intro nested. All right, so here we go. And we print out all the values from 0 up to, but not including 5, right? It's all inclusive here, right? Or sorry, it's inclusive on the left, exclusive on the right. 0, 1, 2, 3, 4, 5, right? Now, if we were to put in so let's start out with a fairly simple nested loop now. okay? 4 in range, and then I'll do 3 this time. Okay, and what I'll do is I'll indent the print statement in this. So basically what this says is that for each of the values in this range, I'm going to print it out 5 times, right? For each value in this range, I'm going to run this loop, okay? And what does running this loop entail? Well, it's just printing a value out 3 times. So 0, 0, 0, 1, 1, 1, 2, 2, 2, and so on and so forth. Make sense for everybody so far? Right? It's not too bad when the repetition is fairly straightforward, right? Where we have where we're repeating and we're not really altering what we're doing over here. The complexity comes when we add in a second variable a lot of the time. This is what you'll be seeing for the multiplication table a lot of the time, where basically we have an I and a J. Why I and J? I for integer, and then J because that's the next letter of the English alphabet, and I guess we ran out of imagination at this point, you know. So again, changing this, just that underscore to J itself does not do anything because we're still printing out I. Okay? So 0, 0, do this 3 times essentially. Now though, let's go ahead and I'm going to throw in I, J, and this kind of, I think, helps illustrate precisely what's going to go on. Okay? And I'm going to print out just kind of a key here. This is completely unnecessary to get the loop running, but it's going to act as kind of a key here. Right? So on the left we have the value of I, and on the right we have the value of J. In our first step in the loop, I's value is 0, and J's value, and then we start the loop. J's values vary from 0 up to but not including 3, so we see for I is equal to 0, we have J is equal to 0, J is equal to 1, and then J is equal to 2. Now, I's value doesn't change because we haven't gotten to the end of the block of this outer loop yet. We haven't gotten to the end of the outer loop yet. I's value is only going to change when it reaches the end of that loop, and then it loops back around to 1, and then we do the inner loop. 1, 0, 1, 1, 1, 2. Now, one great thing about your textbook, I believe if I do this right, if I open up assignments, go back here, right, you've got the scratch pad right over here, right? It's that pen icon, right? If we open that up, right, I'm going to go ahead and copy and paste what I just did over here, the same code that I was writing in idle, and run it, and yeah, okay, it's going to run inside the web browser. Big whoop, right? So, but over here we have this other button, right? Which, because it's all nice and it's all in a black color, and therefore it's not a bright color like save and run. We kind of ignore it. Showing code lens. So this is beautiful, and what I love about this textbook, which is that it will take your code, any code you put in, and it will run through it one step at a time if you want to. So we can hit I, so we print out I and J for I's in range 5. So it says, okay, now I'm going to start keeping track of a value called I, and its value is 0. Then we go to the next, and we say, okay, we've created a value called J. It starts at 0. Print out 1. So I print out that value. Then we go back and we increment J to its next value. So it kind of runs through your code, the green being the line that just executed, and the red being the next line to execute. And it allows you to step through your code and really kind of see it step by step. Other IDEs, like I think Spider probably has this feature, PyCharm almost certainly has a debugger like this, but this is really a valuable tool It says visualize with pythontutor.com. So visualize code in your Python, JavaScript, C, C++, or Java. So if you're having trouble like running through this code and values in your code, like with these nested loops, try using these because this can walk you through it in a way that's going to be a lot better than me just simply droning on and on and on. Because you can actually say, no, actually, what just happened? I can back up or I can jump forward. Okay? It's pretty great for these kind of things. So if you're having trouble following what the code does, just hit the code lens button. It's really useful. All right? So, and again, I'm not expecting you to understand for loops instantly after that. If you're still kind of like going like, for the nested for loops. That's really not something I can help you with until you try writing it yourself and mess up a few times. Okay? It's unfortunate that basically the learning requires making mistakes and fixing mistakes. Yes?
Actually, I was looking for the next step to create a second line.
A second?
Yeah, right, the J line, basically.
Yeah.
Earlier you had just,
I?
yeah.
So here when we are in this, so good question. So here we're in the for I in range 5. That just executed. So we just entered the outer for loop, okay? And and as you can see by the red arrow, that indicates what we're about to execute, which is the for loop, which is saying we're going to read this line that says there's going to be an inner for loop. So once we read that, that creates the J. And so it says print. So now that's value 0. We're going to print out I and J. So we printed that out. Now we say, okay, we just finished that pass of the loop. So we're going back to the top of the loop, and we're going to get our next value, which is 1. Now we're going to print out the value. So we run through the inner loop first. Make sense? Did that answer your question, or?
Somewhat. So that's how you create the second column.
Yeah, the second column is created by me doing the print I, comma j. When I do a print, comma print. So when I do a print variable A, comma variable B, it automatically separates between, separates those two variables with a space. I could easily write it the same. There's a way for me to write it by just simply like using string concatenation, but this is a lot cleaner to do in Python. So again, the main thing that to understand that happens over here is that here we've got I is equal to 0, J is equal to 2. We run the print statement, I and J, to print out 0, 2, to print out those values. And now we're back here, and we're going to execute this line again. What we're asking for is we're asking range for the next value, but we've done 0, 1, and 2 already. So what happens is that it goes, well, there's no more values. You're done with the loop. So let's see. So it increments I, and then we go into the loop again, because we finished that loop, and we run through Z, and so I gets incremented, and we restart the J loop. Okay? Oh, let's see. Was it skipping? Yeah, kind of was skipping there. It's okay. Yeah, it skips there. Give me a second to. Oh, right. There we go. Okay. There it is. I was wondering why it was skipping that. Okay. So there we go. So next line to execute goes I, J, says, oh, there's no more values in the range. So now we're done with the inner loop. We go back to the outer loop, get the new value for the outer loop, which is going from 0 to 1. Then we start the inner loop again, which says, we go to the inner loop again saying, there's an inner loop. Get the value for J for the inner loop and continue going. Basically, work on your inner loop before you get to the outer loop. Okay. Now, basically, when we work with ranges, there's going to be kind of two patterns we see. One is a rectangular pattern, I guess is the best way to put it, if we're going to put it in visual terms, where basically something repeats a certain number of times, right? So basically here, this one is this one I would say is a rectangular pattern, right? Is that each row is each value for I prints out the exact same number of J's, which is 3. Make sense? But the other pattern we commonly see is this triangular pattern, which I call because it involves the triangular number series a lot. So if I instead do I there, okay. Now this one is going to be a bit tricky, but that's okay. Now it says I is equal to 1, I2, I2, 1, I3. So question, which is, again, we're jumping ahead a bit here. Why did I's values are from 0 up to but not including 5? So why is there no print statement that has as I equals 0? Yes? Yep, we immediately kind of increment by 1 because this for loop, we say I is equal to 0, j in range 0 over here. So this loop never runs because you're going from 0 up to 0 inclusive, so this loop never runs. So we immediately come back over here, ask I for the next value. We ask range for its next value, sets I equal to 1. For j in range 0 up to including 1. So what's going on over here is that the range that we're running over changes. It's more of a rectangular pattern, as I've been kind of saying. So it runs something like this amount of times, where the first time it runs, we don't get any output, then we get 1 output, then 2 outputs, then 3 outputs, then 4 outputs. Make sense? Most of it, I don't think I do too much in the way of nested for loops in the exam. There'll probably be something, but not necessarily anything too horrendous. Let's go ahead and talk about the exam some more, though, because that's, I'm sure, what's on the top of your minds now. So unless there's a really good reason for me not to do so, I'm expecting to hold the exam October 3rd. So not next week, but the Tuesday after next week. That gives everybody the chance to go to lab before the exam, and I'll be able to hold a review session on the 28th, right? An explicit review session for this exam. That also means that I'll be happy to share the practice exam with you all. So let's go ahead. So let's go ahead and take a look at some questions that I've asked in the past. So to find where I'm at, you're going to want to go to the textbook, okay, and then go to your assignments. So rather than going to a project, we're going to go ahead and look at the assignments. Let's see, person and assignments. So go click on your assignments, and then you should be seeing over here with like a due date of tomorrow, which is just simply so I could put it in the right place. Practice problems from old quiz 2. This will count as an in-class exercise in terms of grade. So, so basically like any other project. And so let's go ahead and take a look at this. So here's some questions that I've asked in the past on an actual quiz that was for credit, not practice questions, actual questions I've asked. Compute and print the following uses a for loop. If you're unable to see the above math equation, it should read the sum of all numbers from 50 to 100 inclusive, right? So we're going to look at all 4 of my questions first. Second question, arrange the code below so that the shape shown in the image is drawn. So here it's a drag and drop puzzle. Third question is, arrange the code below so the shape in the linked image is drawn, right? So in other words, draw this shape using this code. And then finally, complete the code to draw turn what we have. Basically what we want to turn what we have, which is this, into a T-tetremo, which I'll explain what that is in a second. So let's go ahead and start with the first one, right? Compute and print the following using the for loop. Print the sum of all, the sum of all numbers from 50 to 100 inclusive. Okay? All right, so, and if you can't see where your code box for it, just hit show code and then you'll be able to work on it. Okay, so hit the show code button, which is like this, right? Hide code, show code. And again, to get here, just go to your assignments, then select. To get here again, we just simply select your assignments, or scroll down when you get to your runes, when you open up the page, and you'll scroll down until you see today's date for practice problems from Old Quiz 2. Okay. So pause. All right. So it looks like they've got looks like that they had a Shure SM58 hiding here the entire time. Turns out, if you don't know what an SM58 is, by the way, this microphone basically is a tank. It some people say that it doesn't really work until you throw it into the ocean and retrieve it. These things just can take a beating and keep on going. They're the most popular microphone basically in the world because of that. If you have a musician friend and you need a birthday present for them, an SM57 or an SM58, that will work. So anyway, so when you see math like this, and there was an example of this in the textbook, by the way, with the vector problem in the textbook. When you see math like this is hazing, right? This is mathematicians hazing you. They are making things seem scary because they are using Greek letters. It's not that scary. They are just simply trying to intimidate you. Don't let them. Okay, Greek letters. This is just simply saying we're just summing numbers up, and we're doing a range. And I guess we're doing it this way because it looked cool to somebody, and then it caught on, and then we never tried a different way. Okay, just assume that some mathematician hundreds of years ago did it this way, and somebody thought it looked cool, and therefore that's why we do it forever that way. So don't worry too much about like the math. Again, that's why I said, and yeah, if you're unable to see it, it's because I did some sometimes these math statements don't compile properly depending on the web browser settings. So, okay, to sum numbers up, that's just the for loop for us, right? We're going to be, and that's a running sum. So we're going to need total, okay? First step is spell total correctly, right? Set it equal to 0, okay? And then what we got to do over here is that we want let me just remind myself of what I'm doing. Okay, I'm going to copy that and throw it into a comment so that I'm reminded what I'm doing, the sum of all numbers from 50 to 100 inclusive. I don't really need the reminder, but it's nice, again, to have that reminder in the comments. Make use of your comments so you know what you're doing, when you come back to it in a few weeks or a year or so. So and let's see, what did it say? Yeah, and it said to print it. For blank, for each number in the range of 50 to 100 inclusive. So that's the key there, 50 to 100 inclusive, right? We want to include the 100. We don't want to exclude the 100. So normally when we do this range, that range is 50 to 100, but it's excluding the 100. So in order to do it including the 100, we need this. Now, and then so we would do total is equal to total, the total we currently have, plus this number. Right? So we add up our running sum. Right? We take the total, what our current total is, add the current number to it, and store it in total. Then to get it right, we print total. Now, the one reason I do my quizzes like this is because I could actually, check these values, right? Like checking for hard coding as opposed to just, I didn't want you to simply hit the print statement and just simply, I didn't want you to just simply have print 3825, or I didn't want the students taking the exam to calculate it and then print out 3825 without computing it, Now, for those of you wondering, on an actual exam, what would the penalty have been had you done 100 versus 101? And the answer is very minor. We're talking 1 or 2 points, depending on how many points the problem is. If it was a 5-point question, it'd probably only be 1 point off, or something like that. So I generally, if you've got the general idea and you're showing this kind of mastery, the mastery of most of the material, understand, because there's a lot going on there I can test. The running sum, the range value, as well as just writing a for loop in general that does it correctly. Right? An off by 1 error is fairly fairly innocuous at the end of things. Now, however, when would it be a big thing? If I were to give you this code and ask you find the error in the code, it should be printing out, it should be printing out 3825, and it only prints out 3725. Find the error in the code. That's when it becomes the main topic of it, right? My general rule for my grading is that if you've made a minor mistake but everything else is correct, then if you've got it correct but almost correct, then I start at the full credit and I start taking off a few points. If it's mostly incorrect, I start looking for the things I can give you points for. That is basically the way I grade. I try basically to be as fair as I can about it. All right. So arrange the code below so that the shape shown in the image is drawn. So this is an El Tetrimo from the game Tetris. Tetris was at one point the most widely sold game of all time. It is currently has been displaced by what game? What game is at the top of the charts for the past number of years for the most downloaded game of all time? Yes. Minecraft. That game is at the top. Unsurprising. Yes. Tetris is like number 2. We can like best-selling games. Good to know this kind of stuff. Best-selling video games. Minecraft, Grand Theft Auto 5, and Tetris, and Wii Sports I'm not surprised about. Wii Sports, when the Wii was out, that was, everybody had that game. Okay? Even my mother's not a gamer and she played that game, okay? Everybody had that. It is hard to understate how well that sold. Anyway, so arrange the code below so the shape in the image is drawn. Now the difficulty here, it comes from a few things. First, you don't necessarily know where the turtle started, right? Because if you read this code, one of the things I do is I hide the turtle, which basically says the turtle's gone. So it's a matter of figuring out where it is. But I have kind of two, and it's got multiple functions in here. But you can kind of figure out, like, okay, this import statement, that should probably be first. And then the other thing is, I say first do this, then second do this. So there's a few different ways to do this. But I like these kind of problems, especially when it's something that needs to be auto-graded. Now keep in mind, by the way, that when you're dragging these blocks, like when you do this, def draw El Tetrimo, that there's indentations you can do, right? So you can move in the indentation. So, and the indentation, of course, does matter based on whether or not you're inside a for loop or not. So go ahead, I'll give you some time to do that one too. All right. Yes, question? What? DEF? Define. Define function to make a new command. So basically, the first step is you want to do the import, put in the code to define the. So here we've got a few things we need to do. We need to import the turtle. We've got to, then it says define draw square. So we want to create the command to draw a square. So we fill that out. And then after that, we have the command that will actually do the whole drawing for us, to draw the El Tetrimo. And then finally, at the very end, we call that function. So all the code kind of goes in between these bits. Well, rather, it goes in between, all the code goes in between the draw square and the draw delta tremo, and the draw delta tremo to the draw delta tremo. In fact, if you check it right now, your answer is too short, it will yell at me, but those things are in the relatively correct order there. Yes? If you don't define the function, then it's going to be a lot trickier because we need to define the function to draw a square. If we don't define the function to draw a square, we can't actually use draw square in these blocks later on. All right. So now part of the reason we're doing this is also because I want, does anybody here know what the term metagaming is? Yes. You cheat kind of by breaking the fourth wall. Instead of actually addressing the problem, you address the, so in this case, instead of trying to solve the problem, you try to get inside my head and figure out, oh, how would he do it? As opposed to that. That's actually a pretty useful skill in terms of let's say, schooling, I guess is the best way. It's not something people typically think of. But on the other hand, I'm taking a Japanese class right now. I'm taking JPNS 1001 right now, okay? Now, I've been in the education thing basically my entire life, from kindergarten to now. So by now, after being in school for that long, I kind of understand what professors are going for a test. So when he comes in with his quiz, I generally know, even though he hasn't given me a practice exam or anything, and even though it's a completely different subject material, I know exactly what he's going to be asking because I understand what he's going for. Now, with regards to this, again, I give you the directions here. Now, you don't know necessarily enough about me or the subject to kind of do that yet, but that's also the purpose of the practice exam, because that kind of thing can help you. For instance, let's take a look at the draw square. What does a square have? A square has 4 sides. In other words, we want to do something that repeats 4 times. So that means that we need to take this for loop over here, and that definitely belongs inside the draw square, right? So okay. Well, draw square is not going to run the draw square command, right? So it can't be this thing, and it can't be this thing. And a for loop like this would just not make sense because it doesn't have anything in it. The only other options would be to put this in, or put this in, and then the last one, which is the correct one, this would get overcomplicated. No thank you. So the only thing that makes sense is putting this thing in over here. Draw square for I in range 4. Let me zoom this in. So here we have our first one, which is to get the setup. We draw the square, bob side. Second, create the command to draw square. For I in range 4, move forward that amount, then right turn. That's how we draw a square. We just simply draw a line, we turn 90 degrees, we draw another line, turn 90 degrees, and we just do that a grand total of 4 times. Okay. Now, to draw the L tetremo, okay, how many squares does a tetremo have? It's kind of in the name. It's 4. It's a tetremo. It's a Tetris piece. It's got 4 squares in it. 4 squares. That's why they're called tetremos. 4. Tetra. Okay, so we need to draw a square 4 times. Now, if we look at our remaining blocks, we have a repeat twice block, and we have a thing here that draws 1 square, and we have a block that draws 2 squares. Okay? So we need this for loop in here, and we have a grand total of 2 commands. We have 3 commands. One draws a for loop once. So one draws a square once. One draws 2 squares, and then we have this repetition. So if the for loop and if these things were paired together, the for loop and the draw square, forward, draw square, that would give us 4 squares, and then this one would give us 5 squares if we did this one. This thing has 4 squares, and I've yet to be like overly complicated with these things, right? I've not, I'm generally very direct. I'm not going to like overwrite these squares to be a trick question or something like that. That's just not I find that unnecessary and antagonistic, right? So you can assume that the direct answer would probably be right, which is that we want to repeat this thing twice and do this once. So let's go ahead and actually read what these do now that we've kind of did a high-level overview of these, right? So draw square, we tell Bob to draw square, then we tell him to take, so let's go ahead and actually, instead of trying to do it in our heads, which is always a pain, never try to do things in your head. Always draw it out, okay? So this one says draw square, okay, new whiteboard. Would help if I opened up the whiteboard. Okay. This one says, no, just let me draw. Whiteboard. Draw square. Now, the way that I always like to do things, because again, for me, because I personally love to keep things as easy as possible. So when the turtle draws a square, he starts and ends at the same location, because that makes it easy to predict. So we draw the square, then we say RT, which is short for right turn, so go fade from facing this way to facing this way. Move forward 50, so now the turtle's over here, and left turn 50. Okay, so we drew so the end result is, the end result is we have our turtle, we draw a square, we started here, but we actually end up here, right, in the end. Okay? And so what happens if I run this again? I'm facing this way, so I would draw a square, then I would have the turtle turn this way, move forward, and up here, and turn right. So this would so it ends up there again. So that would either be this part or this part, but it also doesn't make sense that, right, we have basically a command that draws 1 square and one that draws 2 squares. So it makes sense that these things are basically, we would be doing this in 2 and 2. Let's take a look at this bottom part. One that says draw square, this one says draw square, then move forward, so we're here now, and then draw square, and then hide the turtle. So this one pairs directly with this bottom part. So we do the first part. So if we do the first part, so let's go ahead and zoom out now so I can put them in. So we kind of know what to do now. We do the command to draw a square. The first thing we do is for the draw El Tetrimo is we repeat the following twice. Draw square and move down. Draw square and move down. So that gets the turtle over here. And then if we run the next command, it will do this one and end up here, and then do this one and then hide. So, and there. And let's see, right, we have to unindent that, of course, because if that's inside the for loop, that would run twice again. Now, one thing that I've seen students do before, by the way, is this. That's technically correct. I mean, in the sense that it would work. If you did it like that, that would technically work. It's not what I'm going for at all. It would technically work, and I'd give you credit because it technically worked. If it gets you the correct answer, even if it wasn't what I intended, I give you credit, because I can't expect you to read my mind. I really can't, even though that ability does help. But again, that's what so metagaming / meta knowledge, knowing how the questions kind of work, does kind of help sometimes. As well as like, you know, and again, I try to not make you rely on that, but it can help you, like going, okay, right, square 4, so I should look for a for loop that does something 4 times, right? There's also a couple things otherwise to note. The draw over here, you know, you technically can do a define and define, but again, I like readability. Don't do that. It's not right to do that. Similarly, you might also notice that if you think about it technically, whenever we have a for loop over here and we have a draw square, which has a for loop over here, right? So technically, this is a nested for loop. Technically, if you kind of, you know, squint your eyes and look at it, right? It's a for loop. It's a function that's inside a for loop, and that function has a for loop inside of it. This is what I meant by basically functionizing things earlier in the lecture when I talked about, oh, if you've got 3 or more of these loops, turn it into a function. This is a heck of a lot easier to read than a nested for loop, right? A for loop that just simply says to draw a square, right? That's also where the giving the functions good names comes into play. All right, so this is a similar one. Arrange the code below so that the shape shown in the linked image is drawn. So we've got this kind of snowflake-like thing, okay? So we've got this. We can kind of assume that maybe the turtle will, the bob.hide turtle will go to the end. But let's kind of look at this. Import turtle, that should probably go in the top, right? Now, this is actually one that I have given on a paper exam, and I've done it in reverse as well, where I've said, here's the code in the correct order, please draw what occurs, right? This is actually one where I gave the code and I had students draw and asked them to draw this image. Now, let's take a look at it. It's symmetrical in both the horizontal and vertical direction, which means, if we think about it, let's look at our for loops. Oh, there's a for loop in there that repeats 4 times. So, and I see no other loops here. So if we think about that, this thing is a lot like the clock problem in the sense that the way you do the clock in Lab 3 is that you just do the same thing 12 times. You just do it once and turn, and then you repeat that 12 times. Okay, so for this thing, I would focus on, since the turtle is, so let's see. The turtle goes in this direction, so I would focus on figuring out how to draw this. And then there's almost certainly, let's see, is there code to turn it? Reset heading, go to center. Okay, that seems like code to go and reset it. Right? And then, turn for next branch. So, okay. So the first task is focus on getting this and then figure out how that loops. Right? Because all this image is, let's see. Sorry, come on. Why can't I am having the hardest time grabbing onto the edge of this. All this image is this thing basically kind of in a cross pattern. Okay. So I'll pause it and give you the chance to work on this one. Sorry, with only 20 minutes left, I want to make sure that there's plenty of time. A question that I've been asked a few times is like, how would these kind of questions work on the exam? And I should have clarified, these kind of questions, these drag and drop problems, won't be on our, the exam that I'll be giving out on, I think I said it was the 3rd. Yes, the 3rd. It's not going to be this, because these were questions that were designed for students taking exams and quizzes during quarantine. So the entire format is different. The questions are going to be a lot more along the lines of me giving you this code and asking you to draw the appropriate figure, or me giving you the code asking you which of the figures it does draw, while making it multiple choice, or me giving you something like the next question where I say, hey, here's what I have, please, finish drawing it. Right here it's got 3 squares, and then we turn it into the thing with 4 squares. These are great for homework in this kind of format when we're doing the exercises in class. Not so great for a Canvas exam. Canvas doesn't natively support this, and doing exams on Runestones is its own other beast. Mainly because of if technical issues arise during Runestone, I have to go in and manually unlock the exam, whereas Canvas, you just, keep going where you left off. On the other hand, the stuff in here is pretty good for native kind of just running your code. All right, so arrange the code so it's drawn. So this works for the image below. So again, I'm zooming out. So sorry, you'll be able to see it on the screen over here in the recording. But first off, I'm going to go ahead and take what's the very first obvious, what I consider to be the obvious first and last steps. Technically, the hide turtle could go anywhere, I guess, but we're just going to keep. But here we've got import turtle at the top, and we don't have a function here. So the first thing's got to be this for loop, the for loop that's going to move us forward, right? So the for loop would move, the first direction in the for loop is move us forward 50. So then I need to draw these thingies over here, right? Let's go ahead and just check our distances, just eyeballing it. This line segment over here looks about the same as this line segment and this line segment, right? It's a good guess to make that they're 50. Okay, so we've drawn that bit over there. Now I need to, well, it's not going to be this return to center one or turning for the next branch, so it's only going to be one of these two. The turn left, move forward. So if we do the turn left and move forward, so it says turn left 90 and move forward 50. If I turn left 90 and move forward 50, oh no, that's not going to work, right? On the other hand, this one says turn right 45. Now, 45 degree angles are what I need here. Now, the angles I plan on doing on the exam are not going to be extreme. I plan on you can expect, multiples of 90, definitely 45s because those are like your halfway points. Maybe a 30 or a 60, but nothing that you'll need a protractor for, and I'm not going to judge you on your exactness of your angles. You don't need a protractor for this. The idea here is that you got a general understanding of what these kind of things are going to look like. So move forward, turn right 45 degrees, and it says, so turn forward 45 degrees. Then the next line in that block is forward, to go forward, and then backward, so we end up where we are. And now if we run that second line, the bob.left 90, that will make us face this way. So then when we move forward 50, we get that bit. So it's got to be this over here, move right, forward, backwards, then turn left and move forwards. Now we need to work on getting back to the center. So this one says turn 45 degrees, reset, and it has the comment reset heading. So now, because right now Bob is facing at this diagonal over here. So if we make him turn right 45 degrees, he's going to be facing this way again, the way he was originally going. Then we can do pen up and go to 0, 0. The go to moves to an exact point on the Euclidean plane, 0, 0 being the center, right? So that would get him there, and then put the pen back down so he can draw again and turn left 90 degrees. So now he's facing up. And then if we go through it again, that will enable him to go forward, turn right 45 degrees, go forward backwards, turn left 90 degrees, go forward, pen up, move back to the center. Sorry, pen up, turn straight up again, move back to the center, and then turn 90 degrees to the left. All right. So as I was mentioning, this kind of question is a lot more, is definitely the kind of thing you would expect to see on the exam. Where I give you some code that draws picture A, and I tell you to draw and I tell you to finish it up and draw picture B. Now, again, part of the problem of this puzzle is not knowing where the turtle starts in this one. And this one's a bit easier because you can just run it and see where the turtle starts, right, before he disappears, right? But the idea here is that we've got our code here. This code, and then I say, okay, draw your square, tetratremo, and then I say your code below and your code above. So in other words, I'm telling you, I am so sorry. This is what happens when you have a kid. You don't get any sleep. So it doesn't matter what their age is, by the way. So over here we have our tetratremo. We want to put our code, and we want to modify it over here, and we want to modify anything we do over here. Now this one, okay, you can look at it two ways. We have this draw square function, okay, and we've got one draw square, a second draw square, a third draw square, so we need a fourth draw square to make it work, right? Because the tetratremo has 4 squares in it, right? We have 3, we've drawn 4. That's one possible solution. The other possible solution is you go, well, the only difference between this one and this one is this line segment, so I'm going to draw this line segment. Both are equally correct answers, okay? Because my task was draw this, not do it by X. I said draw it by using X. I said draw it. Say, if I want you to do it a specific way, I will tell you to do it a specific way. If it's open-ended, that means that I don't care how you do it, so long as it gets done. Make sense? So let's go ahead and just kind of run this. It says, okay, we define what we need to draw a square of an arbitrary size. First thing we do is we draw that square, then we turn 90 degrees, move forward, and draw another square. Draw a square, turn forward 90 degrees, and so we're there. And so if you follow the code from the center, you end up with this. So now, for using that, go ahead and code in between here, like do thing here, and then another thing here, and then like whatever you need to do over here, right? However many lines it takes. It's not going to be that many lines to complete the code, right? Make sense? Yes?
Draw square, is that a method?
Yep, it's a method that we just defined over here, draw square.
The function.
Yep.
We promised Bob like that.
Bob is the name we're using for the turtle. And I use it because it's 3 letters and 1 syllable long. Alice is 5 letters and 2 syllables long.
I mean, if you don't call Bob within the method, what happens?
If I don't call it Bob within the method, then if I have multiple turtles, it won't know which one to do. So that's why I use it. There's like a default turtle. You can like call it turtle this way, but then every function's using the same turtle, and there's no distinguishing between that turtle.
What do you mean call it as a parameter? Like within?
Yeah, if we don't provide Bob as a parameter, then it's not going to work because basically it's saying draw square here is saying I need a parameter that's the turtle to work. The first one over here is is the name of the turtle, which I just call Bob because I'm lazy, and then the second one over here is the how big is the side of the square. Yes.
So if we didn't have the option to run the code to see where it started, how would we figure out where it started?
What you would need to do is that you'd have to draw it out yourself. You'd have to follow the directions to draw it. And then you'd be able to figure out from there where it is. Or I might take mercy on you and just tell you where it is. It depends on the exam and what I give. So let's go ahead and solve this one over here. I'm going to be lazy about this one. And since the turtle's over here, all I need to do is turn right over here and go up and then draw across over here. So Bob dot right turn 90. Also, you don't want to necessarily leave yet. I'm going to talk about the practice exam in a bit. Bob dot forward, and then how much were we moving forward? 50. So if we run that, that's not going to complete our answer yet, but that's going to get us into a nice position, right? And that got our turtle over to here, right? So now we need to make, and then we can just do this, copy and paste this again. Make one more right turn and then move forward. Yes? Why not just draw square again? I believe because, let's see, either you need to, I forget if you need to turn, let's see, if you're drawing square again. Yep, that's another valid way to do it. For me, when I'm saying it was being lazy to do this, it wasn't being lazy in terms of less code, it was being lazy in terms of less thinking. If that makes any sense, right? All right, so now that we've got that, let's go ahead and announcements, and let's see, files. I believe I have a file. I should have a file over here for the practice exam. Announcement. Okay, and then we have, do I have practice exam here? Status. Really? I don't have it over here? That's weird. I should have it. Uploaded media. New assign. Really? Do I not have my practice exam already loaded up? That is very weird. Okay, no worries. I should have one in my GitHub repository. My other GitHub repository. I've got two. I've got one public facing and I've got one private facing, which I use to build basically all my exams and stuff. So teaching, that's in my private one, and let's see, exam one, practice. So this is back from when I used to do paper exams, but I mean, it doesn't really need to be updated. These exams are so a couple things about this exam. This exam assumes a 1 hour and 50-minute time limit, not a 1 hour and 20-minute time limit. Sorry, the practice exam. Your exam that you'll actually take will assume the time limit you're actually, allowed. It also assumes that you don't have access to a computer. Here on the exam, you're going to have access to your computer, but you're just using the computer to access Canvas. No notes, no running idle this time around. Okay. I'm going to say this now so I can redirect to students later. You have to be here to take this exam, even though it's on Canvas. If you take it not here, that's a 0. I had that happen a few times last semester, and I just kind of threw up my hands, and I'm like, okay, whatever. I guess you don't get credit for that exam, and I'm going to drop it. So no metagaming there. Yes. So, sorry. Yeah, I'll have some way. We'll probably have the TAs here just simply have you check out before you leave, just to write down who was here, rather than necessarily have a passcode up, which somebody could just text to a friend, not you, but just basically make sure, just rudimentary measures, right? I don't try to get into an antagonistic relationship here, but I do have to take some basic measures to make sure that things occur. Now, first off, if you are sick, what should you do? You wake up the day of the exam, the morning of the exam, like 10 o'clock in the morning or whatnot, and you're like, my throat feels like it's been sliced up. I feel like utter crap. What do you do the day of the exam? You email me. And what do you say? You say, I am sick and I cannot come to the exam. Then I will simply tell you to email your TA, CC me, and say, or basically to say, arrange with your TA for a time to make it up. That's how it works. If you can't come because you're sick, okay, then don't come. Please, don't take advantage of this. Don't lie, about it. I'm not going to ask you for a doctor's note or anything, but I do this because I really don't want you to get other students sick, but also it's not going to be representative of your, it's not going to be an accurate assessment of your ability to take the exam. That being said, if you can't take it within like a week, at that point I'll need some documentation, right? I'll need you to take it within a week. Another thing that comes up, which is even easier though, hey professor, I've got like an academic activity that I need to be out, you know, like a track meet or something that's occurring that day. Can I take it early? And I'm like, yes, of course you can take it early. So if that's the kind of thing where you've got something known that's going to conflict, please let me know. So this practice exam has a few different kind of components, but it will have, the different things. I'm going to go ahead and compile it so that it doesn't have the answers already filled in. But it is a fairly extensive practice exams. I make these practice exams to be much longer and much more difficult than the actual exam itself. Okay. All right. So let's go ahead and open up Tech Studio. And